Today I'm going to talk about ICAP, which is about how students engage to learn in active learning. And there's two goals to this talk. The first goal is I want to talk about the theory, the ICAP theory, very briefly because it's been published. And the second part of the talk, I'm going to talk about applications. And in the application, I'm going to show you how you can use it to design a more active learning classroom. So I'm going to go over the terminologies I'm going to use in this talk, just so we're all on the same page. The word instruction is a very broad term. I'm going to use it to include all instructional materials, exercise videos, text lectures, and so forth. So instruction just refers to all learning materials, including lectures. So interacting is another very broad term. You can interact with a peer, with instructional materials, with tools, and with the system. And I'll clarify how I'll use that term later. Constructive is another very general term. It usually in the literature refers to a constructivist approach, which just means that learning is when students are constructing their own understanding rather than instruction, which means you pour information into students' head. So capital S and S refers to students. So constructive, the word constructive is used in a very general sense in the literature. However, the word active and constructive, when it's italicized, refers to a specific ICAP mode that I'll explain in the talk. It does not refer to the general term active learning. And constructive, italicized, refers to a specific ICAP mode. Again, it does not refer to the general notion of the constructivist theoretical approach. So the question that I started out with when I started this research is, what's this active learning? In 2004, Michael Prince quote that active learning is when you engage students in a learning, and it's a process that requires students to do something meaningful, some meaningful learning activities, and think about what they are doing. So do refers to behavioral engagement. So there's a lot of literature on behavioral engagement, and they usually measure the frequency of attending class, turning in homework, accessing course materials in current online environment. So these kind of measures refer to behavioral engagement. So if you take a note of what I just said for those examples, these indices actually measure the initiation or the completion of doing, but not the ongoing behavior of doing. So behavior engagement measures initiation or completion. Active learning, or think about an active learning definition, refers to cognitive engagement. There's also literature on that. And that usually refers to what students are thinking about when they're behaviorally engaged. And there's not very good definition of cognitive engagement other than that in the literature. And it's just not very clear what's going on. So what are the problems and challenges of referring to active learning as either behavioral or cognitive engagement, doing and thinking, faced in the literature and in practice? There are three problems. The first problem is that behavioral engagement, what students do, does not measure behaviors while students are engaged and learning. Instead, they measure, as I said, the initiation and completion of behavioral engagement, like the frequency of turning in homework. The second problem is that cognitive engagement refers to thinking processes while students are doing something, doing active learning, but thinking processes are invisible and difficult to assess, especially by teachers in a classroom. The third problem is that which activities are meaningful learning activities that students should be doing? How do we know an activity is meaningful? There's no definition of what meaningful activities mean. So those are the basic three problems. And there's no clear-cut specification for what activities students should do, what are the characteristics of these activities, and so on. So in practice, what happens is that active learning is simply implemented, at least at a college level, as no lecturing. There's a meta-analysis of 225 college studies on active learning. That's how they define it. And active learning, of course, is better than no active learning. That is, active learning is better than just having faculty lecture. So ICAP's going to address these challenges by assessing what students do while learning, rather than initiation and completion learning, in a way that reflects thinking. And that can be translated into the design of or the choice of student activities. So basically, ICAP addresses the learning processes while students are learning, the process of student learning. So what is ICAP? First of all, it is a theory of active learning, but ICAP is also a science of learning theory. And what does that mean, science of learning theory? And I've only understood this myself recently. That is, what is the science of learning versus the learning sciences? So the science of learning theory means that ICAP defines active learning based on an understanding of how students learn. So ICAP is broad, generalizable theory about how students learn that's applicable to all content domains, grade levels, online or offline learning. And now we're going to try to translate ICAP into practice. ICAP's three basic assumptions that forms theory. The first assumption is that, in contrast to behavioral measures, that's the frequency of turning in homework, physically interacting with instruction appears to be visible also and describes the processes of interacting with instruction versus the beginning and end of engaging. So the first assumption is that I noticed that when students interact with instruction, it's physically visible what they're doing. The second assumption is that the process of interacting with instruction, that is what is physically visible, can be differentiated into 4 different types of modes. And I'll show that to you soon. And finally, the third assumption is that the process of interacting with instruction reflect the thinking processes of learning, thereby how students interact with instruction predicts learning. So based on those 3 assumptions, the theory was developed, and the acronym ICAP stands for 4 behavioral interacting modes in which students can interact with instruction. So I'll go through these 4 modes. The first mode is what I call passive interacting behavior, and you can look at the picture. It's a picture of students attending to or oriented toward instruction, but they're not doing anything else. The second mode is active interacting behavior, in which students are manipulating some aspects of the instructional material, such as pointing to something they're learning or underlining something they're reading. Constructive interactive behavior refers to generating some output with new knowledge, for example, writing some notes. And interactive behaviors is collaborating with a peer in a co-generative way that I'll explain more later. So basically, passive, active, constructive, interactive are labels for the physical behaviors of attending, manipulating, generating, collaborating. And so the active here does not refer to active learning per se. It's italicized, and as I explained earlier, and constructive has specific meaning. So these are the 4 modes. You can see the behavior, the physical behaviors, they do look different, okay? So first of all, ICAP modes are all about on-task behaviors. We're not talking about off-task behaviors, and which is actually irrelevant to ICAP. So which one of these show off-task behavior? Which roles would you say? It's obvious the first role, right, is off-task behavior, because students are not, the one student on the left is not even looking at instruction, but looking at a cell phone, and on the right, they're sleeping. Whereas the bottom row people are looking at the materials. So the reason I bring this up is that there's a little bit, somewhat, I don't know, a little bit or a lot, but some research that a lot of these research is really looking at how to detect off-task behavior. off-task versus on-task behavior. So some of these there are online methods to detect. So I'm not looking at that difference because that's easy to detect. I'm looking only at on-task behavior. So we already talked about which one is the top or the bottom is the top. Okay, so we already said that ICAP asserts and claims that overt behaviors that students interact with instruction can be discriminated into 4 modes by 2 visible indices or 2 visible characteristics, and not by the invisible thinking processes. So the left green column talks about the 2 physical criteria or indices. The first one is what is the physical behavior, which we've talked about. The second one, which we didn't talk about as much, is whether they produce visible outputs and whether the physical output contains information that's beyond what is in instruction. So let's go through the second row in the bottom. So for passive behavior, you're paying attention, but you're not producing any output. So there's no physical output. For active behavior, you are manipulating, and the output, you do produce output, yes, but the output is part of instructional materials. And for constructive, you do produce output, but the output is some information beyond what is given instructional material. And finally, in the interactive mode, each person, yes, you do produce something. Each person produce something beyond what they already know and beyond what beyond the instructional material and beyond what their student contributed. Is that one clear? So they contribute beyond the information given as well as beyond what their partner contributed. So can you think of an activity that fits the 2 indices of this ICAP mode? You're attending physical behavior and you have no output. Which behavior is that? Which mode is that? I'm sorry.
Would that be the passive mode?
Yep, so that would be the passive mode. And so the examples of passive mode is listening to a presentation, looking at a handout, reading what's on the screen, and receiving feedback and so on. Okay, think of an activity that fits the 2 indices of this mode, generating physical behavior, plus the output contain additional information beyond instructional materials. So I've got 3 examples for this one too. Obviously, that's the constructive mode. So you could be drawing a concept map. You could be generating solution to a math problem. You could be doing something much bigger, like creating a video game using programming language. That's a very extensive, large constructive behavior. It could be a constructive behavior could be something minor. I'll clarify that later too. So can you think of an activity that fits the 2 indices of this one where people are reciprocally generating, co-generating behavior, and the outputs contain additional information beyond instructional material and beyond partner's output? That obviously is collaborative behavior, is interactive mode. So it could be, I think could be peer tutoring, depends on the dialogue. It's definitely debating, because debating, you often have to address the other person's point. You have to give justification. Answering each other's question is more or less co-generating. Finally, can you think of activity that fits the 2 indices of this ICAP mode? So you're manipulating physically and your outputs are part of the instructional materials. This is a very common activity that teachers ask students to do. And students like to do things even without being asked, like highlighting key points, copying, now that's copying some sentences from a text rather than copying, measuring a solution in a science class with provided ingredients. So the outputs are component parts of the instructional material. So what I mean by that, when you highlight the sentences are already in the instructional material presented, right? When you copy some sentences, the sentences you copy were already presented. And the solutions you mix are the solutions already provided. However, let me give a clarification next. Here's a clarification. Sometimes the components parts, like the solution you give a student in the lab, can generate new information. For example, the color of the mixed liquid is new. How is this different from the constructed generative mode? Are they being generative if they just combined the solutions, but the solution gave them a new color?
I think it wouldn't be generative because the students aren't themselves creating a new solution. It's the solution itself just reacted within itself.
That's right. That's excellent. But they do gain some new information by looking at the solution color, even though they didn't generate it. So this slide shows for the heuristic of using two indices. Very simple. I made this heuristic so it's easy for instructors and practitioners to just look at this and just gather quickly what they should be doing. I mean, which one is which. Okay, the hierarchical nature of ICAP. What this means is that the 4 engagement modes have a subsuming relationship, both physically, that is one behavior mode of interacting subsumes the other behavior mode, and cognitively. The cognitively subsuming is based on my analysis of the thinking process of each mode. And it seems that one mode includes the thinking process of another. For example, and this is all hypothetical, of course. For example, the constructive mode requires inferring plus activating what you already know, whereas the active mode typically requires only activating your prior knowledge. So this subsuming relationship suggests that engaging in the I mode is better for learning than the C mode, which is better than the A mode and better than the P mode. So ICAP's prediction is that learning effectiveness decreases from I to C to A to P, and I call ICAP because of the nice acronym. That's why I use active and constructive for the C and A, even though it's a little bit confusing with the words in the literature. Anyway, so ICAP predicts learning in this decreasing order. And ICAP's been, in order to see whether ICAP's predictions are accurate, we looked at hundreds of studies. You can just randomly pick a study in the literature, which is exactly what I did. I just went to journals and look at all the journal articles that is relevant in the following way. It's relevant, an article is relevant for ICAP to look at, analyze, is to if they have 2 conditions that I can easily and cleanly map to one of the ICAP mode. So take this example. This whole study compare students summarizing versus student reading, and they show that summarizing was better than reading, okay? Well, based on ICAP, that's because summarizing is at least an active mode and reading is passive. So of course, summarizing is better than reading. Summarizing could also be constructive depending on how students summarize. Okay, another study from Okada and Simon, where they compare pairs of students, I think, solving problems versus individual students solving problem. And again, the pairs of students did better than the individuals. And we can interpret that as interactive collaborative is better than just constructive. So there are hundreds of studies already published in the literature, both classroom and lab studies, that support ICAP's pairwise comparisons. There are also a few studies that compare 3 conditions and that support it, and we ourselves have compared all 4 conditions. So these studies summarize some of these studies, but the second one, my former student, Mineski, Stump, and Kraus, that's the one we look at engineering students performing 4 different modes, and we got systematic decrease in learning from I to C to A to P, looking at pre-test and post-test. Okay, I'm going to talk a little bit more about the interactive mode because it's very complicated. The interactive mode is the most beneficial for learning, but it's very complicated to implement correctly. And it's also difficult for our instructor to detect whether it's implemented correctly. So the way I've described the interactive mode requires a specific way of collaborating that we refer to as reciprocally cogenerative. So I'm just going to talk about 2 students because 3 and 4 and 5 just get complicated. So reciprocally cogenerative means that each partner must be constructive and generative beyond the information presented, but in addition, each partner must build upon the partner's contributions. I'm going to show that on the next slide with my favorite talking head. So collaborating in this ICAP interactive mode means more than physically working together, which is how instructors usually give student instruction, just work together. Rather, it means a specific way of interacting, dialoguing. So let me give you an example. So now I even did it into an extreme case. So in these 2 people, they have exactly the same prior knowledge. N is, or just forget, they have exactly the same knowledge. So reciprocally cogenerative means that each partner infers some new knowledge on their own. So for example, Rishi can, on the left, can infer X and articulate X, right? So Romy now can encode the X and build on the X by inferring Y. So Romy's connecting the X with her prior knowledge N and generate Y. So, and articulate it. After she articulates Y, Rishi can encode the Y, and along with some prior knowledge, the yellow nose prior knowledge that's activated, create another piece of knowledge, Z. So the most important point to know about this is that the new knowledge Y and Z are generated that neither partner could have generated on their own, because it's based on inferring as well as connecting your partner's knowledge and with your own knowledge, and then make some other inferences. So there's some randomness to what you can generate and what your partner can generate. Therefore, by being collaborative actually allows you to be innovative. You can be very creative, and that's the cognitive outcome. So that's the best possible cognitive outcome, but only if you collaborate this way. However, it's difficult to assess reciprocal cogenerative ways of collaborating, especially in a classroom, right? Because even though it has the potential to create the most creative outcome, it's difficult to determine from dialogue behaviors whether students are collaborating in this way, especially if it requires that the instructor listen to students' dialogue and to analyze their contributions on the fly in real time. So that's very difficult. We further assume that there's a bigger learning gap between constructive and active. That is, the passive mode and the active mode leads to learning shallow understanding down here, allowing them mostly for good, accurate recall of instruction. Whereas constructive and interactive modes lead to learning with deeper understanding. The reason being that in constructive interactive mode, you can do inference. You can generate items by the inferring process, which can generate a richer representation. So there's a bigger gap between those, the upper 2 and the lower 2. So what this means is that it's most important to upgrade in practice an instructional activity from passive or active to constructive interactive. Active activities are more prevalent in K-12 classroom than constructive activities. And passive activities are more prevalent in college classrooms because of the prevalence of lectures. The latest index I got was about 60%, especially now with online learning. I think there's a lot of lecturing. So what we really want to do is move students from active to constructive. Okay, now I'm going to go into application